version of a presentation that I provided in Japan a few weeks ago. And there the idea was to really do a bit more of an intro to TEs. What I'll mention here will be like various insights and comments on various presentation work items from various teams on TEs around the MEV problems, solving MEV problems. And if we have time, then feel free to make it a bit more of an interactive session. So I'm Tomasz Stańczak from and Flashbots teams. That's where I usually work on the TE solutions around the MEV. So this is the explanation of what SGX is. I assume that you need it. But actually, for all of those like that you came over here and so like, oh my god, I'm just skipping this. I would like to know what actually TE is. So this is an example of SGX implementation, right? Like so the trustless execution of the hardware somewhere there. Untrusted party, but if you use the hardware, if you use the hardware and can run your system there and trust that it will never leak. And why we need it in the MEV context? Because in the MEV context, we really talk about the trade privacy, right? So we want to execute on financial markets operations, and either we want to, well, usually want to execute some of our algorithms and some of our orders somewhere close to the exchanges, right? So we don't want the details of those orders to leak before the trade. So we care less about the, we care as well about the post-trade privacy, but much less. Like in some situations like dark pools, we care about the post-trade privacy, so that our trade information would never really be leaked to the other parties. But in the majority of the use cases, like the basic use cases, we only care about the pre-trade privacy. We send the order, and before the trade is settled, nobody knows what order we want to execute. Well, SGX theoretically supports the pre-trade privacy, and the post-trade privacy is more of the definitions of how we do it on the chain. Is chain securing encrypted data information, encrypted processing after that or not? And this presentation, I use a bit of an approach of referring to presentations of other people, sometimes referring to presentations of other people. I guess that's a kind of a cultural equivalence of the babushkas in Russia being nested recursively. So first I'll refer to myself, talking about the trusted execution environment markets and thinking that, well, now we start talking about the AI markets, and I started thinking also about the AI regulators, because if you create a market that's kind of on-chain, SGX-enabled dark pool where everyone can send transactions, and inside the dark pool they are being executed there. And what if you can also deploy the AI regulators that will be reading those transactions before the trade appear and check whether they're breaking some rules, like whether someone is doing some shenanigans. You have the AI executed within the private environment, trusted execution environment, and acting based on some kind of verified model. So when we talk about verified AI, we can verify that the AI behaves according to the rules that the regulator would expect, and maybe run it together with all the trades. And maybe one, like when we think about it, the electronic trading is really not that old phenomenon. It's just like 30 years. Well, it started between 70s and 2000s. The electronic trading probably got adopted around the world, right? And now we have 2020. And when we think about the blockchain adoption and the dark pools, how quickly they will spread and how quickly they'll be trading on chain, we should think of many of the inventions that just like were implemented together with electronic trading in traditional finance are coming now to blockchain. And it's very often it allows you to just think a few years ahead, right? Because in 2017-16, when I was thinking about like, what we build on blockchain, I said the hedge funds in the future will be running full nodes of Ethereum on-premise for themselves to have access to the data as fast as possible, low latency access. And it felt very natural, like just look at what happened between 70s and 2000s in traditional finance, and keep looking at all the progression of technologies, of the problems that were being solved, and very often on blockchain you approach exactly the same thing. That's why nowadays we talk about dark pools. This is Andrew Miller from Flashbots talking about this. Look, we have this like amazing opportunity to use at the time the available technology, the hardware-based solutions, to make sure that we can deliver the blockchain networks, the blockchain solutions for trading that are providing this pre-trade privacy and various privacy-related deliveries. But we shouldn't miss the opportunity to design those systems with the use of the technology. And then you see that it's not only Ethereum, there's Cosmos, people here, the informal systems. It's a Berkman suggesting solution with a sidecar using SGX for the validators within the Cosmos ecosystem, upchains, to use SGX for the trusted execution of the trades. Here you have the Flashbots team looking at TDX. So we're talking about SGX, TDX. TDX is a bit of a pretty cool thing that many of the teams say, oh, now it's so much easier to launch the trusted execution environment. We don't have to separate the environment of the virtual machine and the hardware. We can think of the entire virtual machine as the environment where we deploy everything. And a bit like the world, which is closer to how we think about containers and Docker, that it makes everything simpler to deploy. So TDX is definitely a new lab with many of the teams that we're trying to build using SGX. And Gizmo from Flashbots telling how we use TDX in Flashbots for the TV builder. And you see practically all the different providers, infrastructure providers. You could go to all the different cloud providers, but also the producers of the mobile phones, of the various hardware, saying that the privacy confidentiality matters in the aspects of trading, access to your data, and nowadays very, very much AI running on your devices. So because of that interest of the providers in delivering the solutions that will make you feel much more comfortable running AI on your device, there is also the new interest and new narrative saying that, okay, this will work because everyone is looking at it, everyone will be improving it, so let's use it in blockchain now again. And here I was mentioning Automata, but today actually you will learn everything about Automata. So look, Automata is definitely the leading team in the blockchain space on how to use SGX, TDX, and everything else. So what are the challenges? I said that we now trust a bit more to that's like the players like Apple, like Google, like AWS, and so on. They start delivering all of the solutions, even as we were very not trusting because of all the problems with SGX or TDX or other solutions. So we cannot prove everything, but particularly the biggest problem is if I run the trades in some other venue, and let's say at Flashbots we're trying to think of a solution where you as a searcher, you would like to send an algorithm to someone else, and someone else would run your algorithm on top of the order flow and select like how you construct the block on top of this order flow. The problem is that you have to trust that SGX is not only safe like when you execute it locally, like with any code that runs system with SGX, but also that someone who has physical access to the machine will not really tamper the machine and try to do like side channel attacks. And sometimes we can say, well, so you have to trust in majority of the cases, you have to trust that the cloud operator and the hardware producer do not collude, or at least the cloud operator doesn't have the operators who actually get access to the machine and try to extract the data, and they don't collude with potential other party that wants to trade against you. And this is the major issue. Also, if we think that we would like to encourage searchers to run SGX with our code themselves, then we have to suddenly trust them that they will not try to extract that side channel attacks on the hardware vendor side. Let's do this one. And particularly when you look at some of the comments about what the security really, where the system is really secure, then you have the particular analysis of what this is still hardware. The keys are encoded there, are very hard to extract, and so far there were some attacks, and particularly a few weeks ago there was an attack mentioned where one of the keys was extracted, which was later like Intel responded saying that this particular attack doesn't carry much of the significance, But consistently, every few months, we see some types of attacks that say, like, if you have SGX locally, then you can break it properly. So the question is, can you break it only in a single machine, or can you break it across all the machines? Is there something that can reusably, at a low cost, use for all the attacks? And particularly, there's this website called sgx.fail that shows all the various failures around SGX. And why do we talk about the side channels and think about Ethereum when you execute trades? And what you do, you have a state, like the Merkle tree state of Ethereum, and it's stored on the either on the disk, on the I/O access, and or inside the memory, right? So the client nodes can, for optimization for better latency, they can hold quite a lot of the Merkle tree data into RAM, and sometimes they store it, they access it in flat access mode. So practically all the execution clients in Ethereum will have some kind of latent state maintained flat in memory, and only recalculated on the Merkle tree level when it's stored to the disk for calculation of the state trees. Which means that if you're observing over many blocks, over many transactions, which areas of memory or disk are being accessed, then you can start finding patterns. You can start finding like, oh, this is probably some kind of Uniswap ETH USDC trade, and so on and so on. You can check which smart contracts are being accessed, storage of which smart contracts being accessed based on locality, and so on. So the solutions to that usually would go that route of completely surround. So solutions where you probabilistically hide the information about which areas of memory of the I/O of the disk you're accessing. So for every single access, you practically produce multiple different access levels, and you build proper cryptographic method of constructing various Merkle trees of access, and trying to introduce the minimal possible latency while introducing probabilistically possible way of decoding which areas of memory you're accessing. Why do we say that TEs ultimately are secured by economics? Because of that collusion idea, that in the end, you assume that TEs are running within the cloud infrastructure, and there are some significant reputation risks of either the hardware producer or the cloud operator, or more or less like both of them together, right? So ultimately, we asking, would a producer like Intel or AMD or RM would sacrifice the keys that they're maintaining for some financial gain? So this is in the end secured by economics, and like, are they going to sacrifice hundreds of billions of dollars of the value of the company to extract potential valuable trade? Because the moment when you start trading at a higher level, then someone can say, actually, I would like to sacrifice the entire company. So the Gs were brought to the protocols on the blockchain side like a few years back, and people started experimenting. And you see here is for oracles, bridges, payment channels, when we talk about the account encumbrance. So the solutions where you have a private key for your account in Web3, and you decide to provide the private key to the operator of the SGX or other TE, and say that actually I trust that my private key will not be extracted, so the machine can start signing on my behalf. So I can do a bit of approach like nowadays the session keys, say this is the rules under which my key may be used for signing transactions, and the SGX operator will keep signing and can trade on my account. And similarly, for any kind of rules around the account, creating some kind of like account abstraction smart account with the access to the private key. Automata will talk about their solutions. And then you had also like papers and approaches of how to combine the trust within the hardware around the solutions with the network solutions, where you actually can create the requirements that you only have to trust some subset of nodes operating the TEs. So you don't have to worry that maybe one of them will be broken. So you start combining the hardware solutions with various other approaches, like you can think of MPC plus TEs or other solutions that you could read about the ZNet proposal. And many of those mentioned presentations are from SBC Conference 24, and also like if you go to the Flashbots videos on YouTube, you'll find a lot of materials and talks and commentaries about TE. How do I extend on the time? Yes, still have a few minutes? Okay. Here we're talking about the programmable privacy. What do we mean when we talk programmable privacy? It means that as a searcher or as a trader, I can send the trade together with a set of instructions, conditional instructions that say, I would like to disclose some bits of information based on some conditions being met. So I would say, I can only give you the details about some parts of my trade if you promise me that you will backrun and pay me back some value of the transactional money that you made on top of my transaction. So practically creates the full control of the sender of the transaction on what to say about the content based on the expected outcomes and conditional, maybe market conditions, or maybe the promises made by others. So we're combining the capacity of a smart contract and the environment and the various graphical concepts and ability of describing, providing the metadata, meta information to the trade. Once again, I have to refer to myself, talking about the ability to create the solutions for the composable block building within the context of the block builders running together within some kind of dark pool like environment, TE environment, where multiple different block builders can start collaborating to create the block together. So what if I start building the block and then think, I have some few million gas left, and then some other block builder can add it on top. And because we're running within the TE, we don't have to trust each other. We can collect the best opportunities and potentially together win over blocks from other parties. Which also for the Automata solutions was proposed maybe in these different forms, where you actually do something like top of the block building and then the rest of the block being executed. So you see here most profitable top of the block and the rest of the block, multiple builders working together with the usage of TEs. And here you have Shay presenting the TE builder and the approach of Flashbots to how to use TE in the block building. So I encourage you all to look at what Flashbots is preparing with the TE block builder, operating it and providing the entire infrastructure of swap connected with TE building and using the trusted execution environment a bit as a proxy for the future of probably using FHE or combinations of various cryptographical methods for trading in the dark pools. The last thing here is you see, like, we have many of those teams collaborating together. So when we talk about the ORAM, we look about the examples of the usage of TEs in the on-chain trading. So the teams that were presenting at the SBC conference do cross-reference, and I think those babushkas are important in a way of thinking that the entire industry are using each other's improvements and ideas to build together the markets, and it's relevant, and many top teams are talking about it. And practically, what is important in blockchain, once again, is the driver of much of the progress within the cryptography and also the hardware TEs. And the dark pool stocks, something that I keep reminding people that is like very, very natural to think that we should use blockchain dark pools idea when thinking about how we trade on blockchain. It solves a lot of problems as look, just as here, so you have a proper multiple nesting. So the dark pools is the way of saying, look, the blockchain provides the solutions that really do things that in the traditional finance do not work, because you have to have regulators looking over even the implementers of the dark pools, but you can do that in a decentralized permissionless way within the blockchain environment. So really we can ultimately say, look, through blockchain we deliver massive improvements over the financial markets. Thank you so much for listening.